Okay, good morning, students. So, in the last class, we're discussing about the problems based on Kirchhoff voltage law and Kirchhoff current law. That is mesh analysis and nodal analysis. So, I think you are clear about how to apply the mesh analysis and nodal analysis. And in today's class, we're discussing about the some theorems. So, our first theorem is the superposition theorem. Superposition theorem. So, here So before going to solve some problems, we just explain what is the procedure and how we can solve by using superposition theorem. So, so first we just remembering that. So while applying the superposition theorem for any circuit, so the circuit must be consisting of two or more sources. So here to apply superposition theorem, the circuit must be having two or more sources. So then only we should apply the superposition theorem. See the suppose the given circuit is doesn't having two or more, so less than two. If there is any single voltage source, we cannot apply superposition theorem. So the given circuit must be consisting of two or more sources. And also this superposition theorem is always applicable for linear and bilateral circuits. Linear and bilateral circuits. Okay, so this superposition theorem is applicable for linear and bilateral circuits, and the circuit must be consisting of two or more sources. So first, what is the statement of this superposition theorem? So the superposition theorem can be states that in any linear and bilateral network consisting of two or more sources, then the response of any element is equal to the algebraic sum of the responses caused by individual sources acting alone. So this is the statement of superposition theorem. So you just clearly understand this statement by taking one of the example. So suppose we are taking one circuit. Suppose it is the resistor 1, resistor 2, and this is the resistor 3, and it is having some two voltage sources. This is the source 1 and this is the source 2. So resistor R1, R2 and R3. So here this is the voltage source 1, this is the voltage source 2. Suppose if they are asking to find the current through particular R1 or R2 or R3, so they are asking to find the current through any one of the particular element. So in that case, by that procedure that is solved by using superposition theorem. So for this circuit, to apply the superposition theorem or to find the current through particular element by using superposition theorem, how we can find, we just see. So it can be solved in three different cases. So in first case, we just take both the sources are acting alone. So here number of sources will be 2. So already we discussing to apply the superposition theorem for any particular circuit, that circuit must be consisting of two sources. So here V1 is the source 1, V2 is the source 2. So not only the voltage sources, two or more sources means that is a two voltage sources or two current sources or one voltage source or one current source, whatever it the, that must be consisting of two or more sources. So in case 1 we are taking both the sources are acting. Both the sources are acting. Suppose if they are asking to find the current through this particular resistance R2, suppose here. So when both the sources are acting, so then the circuit will be drawn the same. This is the resistor R1 and resistor R2. This is the resistor R3. So R1, R2 and R3. What about voltage sources? Here we are assuming both the sources are acting. That means voltage source 1 will be present and voltage source 2 is also present. So this is the voltage source 1 and this is the voltage source 2. So now we are going to find the current through this particular R2. So that is by applying mesh analysis or nodal analysis. So whatever it may be, you just apply the mesh or nodal and find the current through R2. So this is when both the sources are acting alone. And next, second case, here any one of the sources acting alone. Suppose V1 is acting alone. V1 source is acting alone. So here only one source will be acting alone. So that will be taken as this is the R1, R2, and this is the R3. So here only V1 is acting alone, means only V1 is present. So this is the source 1, V1, R1, R2, and R3. So what about this? Here only V1 is active, V2 is inactive. So the inactive circuit is voltage source, then that must be open circuited. Suppose if the inactive circuit is current, so that must be short circuited. So when it is a voltage source, that must be short circuited. We just short this voltage V2. So here the inactive circuit is voltage source. So whenever the inactive circuit is voltage source, so that should be short circuited. If suppose the inactive circuit is current source, that should be open circuited. So now when V1 source is acting alone, this is the circuit. So here also we have to find the current through R2 only by applying mesh or nodal analysis. So any one of the method you just apply and find the current through R2. So this is the second case, that is only source V1 is acting. Next, third case. Third case is the source V2 source is acting alone. V2 source is acting alone. So again you just draw the circuit. So here resistor R1, resistor R2, and resistor R3. This is the R1, R2, and R3. So here resistor, the source V2 is only active. That means V2 will be present, plus minus, and this is the V2. Then what about V1? Here only source V1 is active, means V2 is inactive. So whenever the inactive circuit is voltage source, that should be short circuited. So this is the third case. Here also this is the R2. Okay, this is the R2 and this is the R3. So here also we just find the current through this particular R2 only by applying nodal analysis or mesh analysis. So by using this we can find the we can apply the superposition theorem. So to clearly understand the process of superposition theorem, we just take one example and we can solve that problem. So then you will clearly understand what is the when both are acting, when V1 is acting, when V2 is acting. So how we can solve this procedure and how we can solve this problem, we see. So we just take one example based on the superposition theorem. Okay. So let us consider one of the circuit, and for that circuit we have to apply the superposition theorem. Suppose so this is the one of the circuit, and for this circuit we are assuming some values. So suppose this is the 25 ohm resistance. So here minus plus, and here some voltage source is 60 volts. Just assume this is the 20 volts, 20 ohms, and this is the 15 ohms, and this is the 5 ohms. So here also minus plus 60. ఇక్కడ కూడా 60. Okay, no problem. Both are 60. And this is the some 10 ohm resistance. So here this is the circuit. So for this circuit we have to find the current through 15 ohm resistance. So by applying the superposition theorem, we just find the current through 15 ohm resistance. So before applying the superposition theorem, we just check the number of sources will be 2 or more. So here 60 volts voltage source, here also 160 volt voltage source, two sources will be there. So we can apply the superposition theorem. So we can solve this in the three cases. So number of sources equal to 2. So first both the sources are active. Next one of the voltage 60 volts is active in second case, and next another 60 volt is active in third case. So first we just take case 1. So for this case 1 we are taking both the sources are acting. Both the sources are acting. So when both the sources are acting, we just draw the same circuit. So by drawing the same circuit, we just I am taking this circuit only. So here number of loops will be 2. So this is the some points given here also, A, B, C and D. So here A, B, D, A is the loop 1. And next second is a B, C, D, B is the loop 2. So number of loops equal to 2. So we just assume we are applying either a nodal or a mesh. Suppose I am taking a mesh. So suppose this is the current I1 and this is the current I2. I am assuming the current directions. And again you just apply the mesh analysis to the loop 1 and loop 2. First apply KVL to loop A, B, D, A. Apply KVL to loop A, B, D, A. So then we get the equation as minus 60 plus 10I1 plus 15 of I1 minus I2. So we are taking like this. So our assumed direction is clockwise. So minus 60 plus 10I1 plus 15 of I1 minus I2 plus 5I1 is equal to 0. So now simplify this equation. So by simplifying we get this equation as minus 60 plus 10I1 plus 15I1 minus 15I2 plus 5I1 equals to 0. So how many coefficients of I1s? 10I1 plus 15I1, 25I1 plus 5I1, 30I1. So 10 plus 15, 25 plus 5, 30. Next minus 15 I2 this, and constant is minus 60 equals to 0. So therefore 30 I1 minus 15 I2 equals to 60. That is the equation 1. So in the same way just apply a mesh analysis KVL to loop 2. What is the loop 2? Loop 2 is the B, C, D, B. So for that again you just apply. So that is the 20 I2 next plus 60 plus 25 I2 next plus 15 of I2 minus I1 is equals to 0. Just simplify this equation, then we get 20 I2 plus 60 plus 25 I2 plus 15 I2 minus 15 I1 equals to 0. Just simplify I1s. Only one, that is minus 15 I1. Next 20 I2 plus 25 I2, 45 I2 plus 15 I2 plus 60 I2 plus 60 equals to 0. Therefore 15 I1 minus 16 I2 is equal to 60. So by applying mesh analysis to both the loops, we get two equations. So on solving these two equations, we get I1 and I2. So after getting the I1 and I2, our aim is to find the current through 15 ohm resistance. So suppose if they are asking the find the current through 10 ohm resistance, then I1 is the answer. Suppose if they are asking find the current through 20 ohm resistance, then I2 is the answer. But they are asking to find the current through 15 ohm resistance. So here this 15 ohm resistance is linked with both loop 1 and loop 2. So after getting I1 and I2, we just doing I1 minus I2. So that is the answer, and that is the current flowing through 15 ohm resistance. So here what is the I1 minus I2? So after getting I1 and I2, we just doing I1 minus I2. So here the I1 minus I2 is equals to 2.5 285. So this is the I1 minus I2 equals to 2.285. So this is the case when both the sources are acting alone. So this is the case 1. So next case 2, any one of the 60 volts is active, and next so in case 2, suppose we are taking these 60 volts is active, so then the upper case 60 volts is inactive. So first downward 60 volts is active we are taking in case 2. Case 2, so 60 volts is acting alone. So here render 60, both we are taking both the 60 volts. Suppose this is a downward 60, so both are 60, one is assumed as upward and second one is a downward. So bottom 60 volts is active. So then draw the circuit. So then the circuit will becomes 10 ohm resistance, again here 120 ohm resistance, and at here 25, again one voltage source. So here one voltage source will be there, that is short circuited, and one more resistance will be there, that is 5 ohm resistance at here. This is the 5 ohms, this is the 25 ohms. So here this is the minus plus 60 volts, and this is the 20 ohm resistance, and this is the 10 ohm resistance. Okay, so this is the circuit, and here this is the 15 ohm resistance. So here bottom of 60 volts is active and another 60 volts is inactive. So here again we need to find the current through 15 ohm resistance, that is either by applying mesh analysis or nodal analysis. Suppose here also I am assuming the mesh, this is the I1 and this is the I2. So again you just write the equations by applying mesh analysis. So for loop 1, so for loop 1 we just write the equations, that is 5i1 plus 10i1 plus 15 of i1 minus i2 is equal to 0. So by simplifying this we get the equation as 30i1 and minus 15 I2 equals to 0. This is the equation 1. So in the same way just apply mesh analysis to the loop 2. So mesh analysis to the loop 2. So then you may get that is 15 of for loop 2 means you have to write I2 minus I1. So 15 of I2 minus I2 minus I1 plus 20 I2 plus 60 plus 25 I2 equals to 0. So you just simplify this equation also. So then we get this is the 15 I1 minus 60 I2 is equal to 60. That is the equation 2. So by applying the mesh analysis to the both the loops, we get two equations. Again, you just solve these two equations by using calc. So then we get I1 and I2. So here the value of I1 is equals to minus 0.571 and I2 is equals to minus 1.142. So here we need to find the current through 15 ohm resistance. So that is linked with both the loops. So we just solve, that is I1 minus I2. So what is here, we get I1 minus I2 equals to 0.571. So this is the answer, that is 15 ohm resistance when 60 volts is active. Only a bottom of 60 volts is active. So then we get I1 minus I2 equals to 0.571. Okay, so in the next case we are taking one more 60 volts is active. So then also we need to find the current through 15 ohm resistance. Case 3, so here also 60 volts is active. So here also the 60 volts is active. So here just draw the circuit again. So here top 60 volts is active. So then the circuit will becomes So here one voltage source is there, that is short circuited. Again here 120 ohm resistance will be there, and this is the 15 ohm resistance. So here 20, and this is the 25, and this is the 15 ohm resistance. This is the 5 ohm resistance, and minus plus 60 volts, and here one more resistance is there, that is the 10 ohm resistance. So for this circuit also you just apply the mesh analysis and again find the current through 15 ohm resistance. You just apply equations for loop 1. So for loop 1 we get the equation as 5i1 minus 60 plus 10i1 plus 15 of I1 minus I2. According to our azimuth direction, we can write this equation, that is equals to 0. So by simplifying these equations, we get as the equation is 30I1 minus 15I2 equals to 60. That is the equation 1. So in the same way, just apply the mesh analysis to the loop 2. So then we get the equation 2 as that is the 15 of I2 minus I1. Next one చూడండి 20. So that is the 20 I2 plus one more resistance 25 I2 is equal to 0. So by simplifying these equations, we get the equation as 15 I1 minus 60 I2 is equal to 0. This is the equation 2. So now on solving these two equations 1 and 2, solve 1 and 2, then we get I1 and I2. So what is the I1 here? So by solving this we get I1 as 2.28 and I2 is 0.571. So here we need to find the current through 15 ohm resistance. That 15 ohm resistance is linked with loop 1 and loop 2. That means I1 minus I2. So what is the value of I1 minus I2? I1 minus I2 is the 1.71. So here what we are getting, so in when both the sources are active, so when both the sources are active we getting 2.28. So when only V1 is active, then we get 0.571, and when only V2 is active, then we get 1.71. So only V1 is active plus only V2 is active. So ఈ రెండింటిని మనం యాడ్ చేయాలి. So that is here we get 1.71 plus, and in the previous case we get 0.571. 0.571. So this is the case 2 and this is the case 3. And what about case 1? Case 1 is 2.285. This is the case 1. So here this is the 2.285. By adding these also we get 2.285. So now we clearly understand the statement of superposition theorem. The superposition theorem states that in any linear bilateral network, so the circuit consisting of two or more sources, then the response of any element is equal to the algebraic sum of the responses caused by individual sources acting alone. So in the case 1 what we are getting, so by adding remaining cases also we get the same answer. So that is the statement of superposition theorem. Okay, it is clear. Okay, thank you. So next theorem we will discuss in the next class. Thank you.